stones are thrown up simultaneously from the edge of a cliff 200 meter high with initial speed of 15 meter per second and 30 meter per second. Verify that the graph shown in the figure given below correctly represents the time variation of the relative position of the second stone with respect to the first. Neglect air resistance and assume that the stones do not rebound after hitting the ground. We are considering g equals 10 meter per second square, and we have to give the equation for the linear and curved part of the plot. So for this particular question, let me first of all explain you the situation, the way we will be solving this particular problem. So we are considering that this is the cliff from which the stones are thrown up simultaneously, and the height of the cliff is 200 meter. The first ball is projected up from here. This is the first ball, the red ball, with a speed of 15 meter per second, while the second ball, which is the green ball, is projected up with a velocity of 30 meter per second, that is twice the speed. So it is obviously evident that the ball projected with a less speed will hit the ground first and will not rebound back according to the question. And I can say that the displacement of the first ball, this is going to be x naught. We will be measuring the distance from the ground. We will be measuring the distances from the ground. So for the first stone, okay. So we are writing equation from the ground. So for the first stone, so we are writing the equations for the first stone. For first stone, so we take initial velocity as positive in the upward direction plus 15 meter per second, and acceleration in the downward direction, that is minus 10 meter per second square. So we are writing that the position of the first ball, x1, is going to be x naught, that is the distance from the ground which is already added, plus ut plus half at square. So u1t plus half at square. Obviously this value will be put as negative, and x naught is equal to 200. So from here we get x1 equals 200 plus 15t minus on putting over here 10, we get 5t square. So this is the first equation which we have. If we solve this equation, that is for the time when the stone hits the ground, that is x1 is equal to 0. So we get a quadratic equation in t, and on removing 5, we can write it as t square minus 3t minus 40 equals 0. On solving this equation, we get t equals 8 seconds. And this is the reason why in the graph till 8 seconds we are seeing a particular type of the graph, and after which the nature of the graph is changing. So now since the stone projected was at t equal to 0, so we have taken till t equal to 8 seconds. So now let us write equation for the second stone. So we are writing equation for the second stone. So for second stone, ut equals 30 meter per second, and acceleration is the same, minus 10 meter per second square. So if we write x2, we can write it as x2 equals x naught, which is the original height of the cliff, plus u2t, which was in the upward direction, plus half at square, which we will put it in the negative sense. So we say x2 equals 200 plus 30t minus 5t square. So this is the second equation which we have for the second stone. So the time for the second stone to hit the ground, that is x2, will become equal to 0 when the second stone hits the ground. And we can again modify this equation into taking 5 common, t square minus 60 minus 40 equals 0. So on solving this equation, we get t equals 10 seconds. So from the equation of x1 and x2, we can say that the relative position, so now we are talking about the relative position of the two stones. The relative position of the two stones. So we can say that the relative position of two stones can be written as x2 minus x1. And if we put this over there, x2 minus x1, so we are having this equation as 200 plus 30t minus 5t square subtracted with 200 plus 15t minus 5t square. 200 plus 15t minus 5t square. So on solving, we obtain x2 minus x1 equals 15t. So that is, we say that the nature of the graph will be linear. So the nature of x2 minus x1 is going to be linear, and the maximum separation, let us go back to graph. So the graph is going to be linear, x2 minus x1 equals 15t. And if we look at this equation, we can clearly see that at t equal to 8 seconds, on putting in the equation, we get 120 meter. So now the problem is, at t equals 8 seconds, only second stone will be in motion, because after striking the ground, the first stone will come to rest. And the quadratic equation which we obtain for the second stone, that is 200 plus 30t minus 5t square, will only be evident after the first stone strikes. So after the first stone strikes, that is after 8 seconds, the equation which we have, x2 x1 will become 0. So we have x2 minus x1 as 200 plus 30t minus 5t square, which is a equation of curved path, and hence the equation after the first stone strikes is a curved path. So we have given an explanation for this graph, and have also written the equation for the linear part, which is this one, and for the curved path.